6.4 Evaluation and feedback for future actions. Using notation analysis, we can see that Charlie's team covered a larger distance of 1,750 metres compared to Aaron's team, which covered 1,625 metres, which would suggest that Charlie's team worked harder. Aaron's team had an average of 3.2 two-pointers attempted, whereas Charlie's team got 1.4 attempts on average, which would suggest that Aaron's team was stronger. However, of the 3.25 attempted by Aaron's team, only one on average went in the basket. Charlie's team converted 0.8 of their 1.4 attempts into successful shots, which would suggest that they are better at scoring. Compared to the average of the entire group, 2.78, Aaron's team were above average in their 2 points attempted, but Charlie's team were below average. Within Aaron's team, according to notation analysis, Aaron was the strongest player. He covered the most distance, 2,000 metres. He attempted the most 2-pointers, 5, and 3-pointers, 3. His overall score was 10, the best in the team, compared to the second best player, Charles P., who scored 6 in total. Within Charlie's team, according to notation analysis, Charlie was second in metres covered. He was the second highest scorer on 2 and 3-pointers, scoring a total of 4 points. Obe scored 5. Charlie got 1 defensive rebound, which was the second best in the team. According to notation analysis, Charlie would appear to be the second best player in his team. Analysis of the notational data shows that Aaron attempted more 2-pointers, but scored the same number as Charlie. This would suggest that Charlie is the better player because he has a 100% success rate. However, it does show that Aaron was more involved in the game, and this is what you need to be a power forward. Aaron attempted more 3-pointers, 3, and scored 2, whereas Charlie attempted 1 and scored 0. This would suggest that Aaron is a stronger attacking player. Both Aaron and Charlie had a 50% success rate with their free throws, but whereas Aaron attempted 4 and scored 2, Charlie attempted 2 and scored 1. Aaron would therefore seem to be the better player because he has attempted more and scored more, even though they had the same percentage success rate. Aaron made 2 steals and Charlie made 1. Neither player made an offensive rebound, but Charlie achieved 1 defensive rebound. According to the data, Aaron wins 3 of the performance criteria categories, and Charlie wins 2. This would suggest that Aaron is the better power forward and should be chosen. Also, the categories that Aaron wins, he does so very clearly, which can easily be seen when looking at the graph. According to notation analysis, Aaron's strength is in his attacking play. For instance, he attempts 5 2-pointers, which is the third highest out of all the players in all of the teams. He scores the joint second highest out of any player in all the teams. He is the second most successful player attempting and scoring free throws. He attempts 4 and scores 2. Only Obe is more successful, attempting and scoring 3. On 3-pointers, he attempted and made. Aaron is second to Ellis. Aaron attempts 3 and scores 2. Ellis attempts 5 and scores 3. Aaron covered 2,000 metres, which is the second highest out of all the players, which would suggest that he was working hard. Although Aaron is a very capable attacking player, he could further improve his shot accuracy. Aaron's weakness as a player is in his defensive play. Aaron made 2 steals, which is 1 more than the mean average, so he did reasonably well with steals. However, he underperformed with rebounds compared to his game as a whole. The mean average for defensive rebounds is 3, and for offensive rebounds is 2, but Aaron made 0 defensive or offensive rebounds. Using notation analysis, I have identified defensive play as the main weakness in Aaron's game. In order to improve his defensive play, Aaron is going to target rebounds for the next 4 matches he plays. In the first match, he will achieve at least 1 offensive and defensive rebound, building up to 3 of each in match 3. This meets the SMART target because it is specific to the weakness in his game. It is measurable because it can be monitored by his coach. It is achievable because Aaron is a capable player. It is realistic because it isn't too hard for him. It is time-bound to the next 4 matches. By the end of the 4 matches, it should be a normal part of his game. A weakness is Aaron's scoring success. In order to improve his scoring rate, I recommend that he spends at least 10 minutes after every session for the next 2 weeks practicing 2 and 3 pointers. This meets the SMART target because it is specific to the weakness in his game, it is measurable because it can be monitored by his coach, it is achievable because Aaron is a capable player, it is realistic because it isn't too hard for him, it is time-bound to the next 2 weeks. When comparing the whole class's impulse and jump height, there was a strong positive correlation between how large the impulse was and how high the participants jumped. The R value was 0.87 between -1 and +1, which shows that there was a strong positive correlation because 0.87 is close to 1. This means that how large someone's impulse is determines how high they can jump. Also, the p-value was 0, which suggests that the data was reliable and valid. This means that the correlation is true because there was one small anomaly, data 13, measure 1, 313, and measure 2, 1.37, which might have slightly affected the trend of the graph, but will not have a dramatic impact. Between the height and time in the air, there is a moderately positive correlation because the R value is 0.4, which is 0.54 off of 1. This means that there is a possibility that if you're taller, then you have a longer time in the air, but there's also a possibility that height is not linked to time in the air at all. The p-value is 0.057. This means that the result is probably down to luck, because it is over 0.05, which suggests that the data isn't reliable or valid. A reason for this could be that there is one large anomaly that does alter the general trend of the graph. Data 15, measure 2, 830. It is not surprising that a strong link cannot be made between height and time in the air because jumping relies on powerful leg muscles, which do not depend on how tall you are. However, when you think about sports such as high jumping, the athletes are usually tall and thin. The whole class's mass compared to their max force is not directly linked because the R value is 0.47, which shows that there is a moderately positive correlation because 0.47 is almost halfway to 1. This would suggest that possibly a greater mass results in a larger force. Sometimes, depending on the mass, the max force is larger, but not every time. The p-value is 0.048, which means that the data isn't very reliable because it is just under 0.05. One reason why the data is unreliable is because of a large anomaly, data 17, measure 2, 3727.1. For their max force is not possible. Therefore, this must be an anomaly in the data which affects the overall data and the trend of the graph. If the large anomaly was to be removed from the data, there is a possibility that a correlation could be shown between mass and force. Charlie jumped higher than Aaron on all 3 jumps. One reason why Charlie could be better than Aaron at jumping could be because Charlie is 180 centimeters tall, whereas Aaron is 173 centimeters tall. When you think of athletes who are good at jumping, for instance high jumpers, they are usually tall and thin. However, our data does not support this theory because we did not find a correlation between height and time in the air. The data shows that Charlie has a greater max force output than Aaron, which means that Charlie has a better muscle to weight ratio and is therefore stronger when it comes to lifting his own body weight. Charlie is the less experienced player and has a higher propulsion impulse at all of the jumps. On the 45-degree jump, Charlie got 170 newtons of propulsion, whereas Aaron got 154 newtons of propulsion. Charlie is more able at jumping because he was 18 newtons more powerful than Aaron. Charlie jumped higher on the 45 and 90-degree jumps, and this could have been because Aaron held an isometric contraction for a long period of time before he jumped, because the angle took a long time to measure, and this might have affected the results. Also, Charlie didn't stay at 90 or 45 degrees, so he'll have had an advantage. Charlie I is 100 centimeters tall, which is 3.8 centimeters over the average of the class, whereas Aaron was only 173 centimeters, which is 4.2 centimeters below the average and 7 centimeters smaller than Charlie. However, even though Charlie is taller than Aaron, Charlie's mass is 63.2 kg, whereas Aaron is 64.3 kg. Compared to the mean of the whole group, both of the players are below the average. This data shows that Aaron might have a denser muscle mass, which can mean that he has a greater impulse, but Charlie has 188 newtons of propulsion, and Aaron only has 174 newtons of propulsion. Charlie is just over the mean for the group, whereas Aaron is below the mean. Finally, Charlie has a larger max force, 1,573 newtons, whereas Aaron has a smaller max force, 1,561 newtons. Charlie and Aaron are both below the group average, but Will's data seems to be an anomaly which can affect the average of the entire group because it is very different to all the other data. Charlie has a larger force, and this could be one reason why Charlie had a larger time in the air. Charlie was above the average for the time in the air, 617 milliseconds, but Aaron got 523 milliseconds, which was below the average. The stretch reflex cycle is a protective mechanism to stop us from tearing tendons. When the muscle stretches, a message is sent through the sensory neurons to the spine, which sends a message back to the muscle via the motor neuron to contract in order to protect the tendons. The message bypasses the brain altogether, so the message is automatic and happens extremely quickly. The stretch-shorten cycle is used in sports performance to increase power. By doing powerlifting and plyometric training, a person can use their stretch reflex muscles to help them perform better and more efficiently. If you're doing a power lift and you do a quick downwards followed by an upward movement with your legs, then you get more power in your lift. If you bend your legs slowly, then the power dissipates into heat and you have less effective lift or jump. According to the numerical model, Aaron's main weakness is his jump height. Charlie is an inexperienced basketball player, yet his jumping is better than Aaron's. Charlie jumped higher in the 45, 90-degree and counter-movement jumps. In order to improve his jump and therefore his rebounding in basketball, Aaron needs to incorporate plyometric exercises into his training program on a regular weekly basis. For example, he could do 10 box jumps at a challenging height at the end of every training session. This would also help his leg strength and his power. He could add variety by doing lunge jumps and squat jumps. These are the two videos of Charlie and Aaron rebounding. The good thing about the technical model is that you can actually watch your athlete playing basketball and see them put their skills into action. You immediately notice that Aaron is a talented player. He appears to move about the court smoothly and effortlessly, and he is clearly the best player in his team and one of the best in all of the teams. With the numerical and notational models, you don't really recognise how good he is. However, they do pick up his weaknesses and give him a good idea of what he can improve if he wants to be a better player. The technical model looks at technique, where Aaron's experience really shows, and he does better than inexperienced Charlie.